Good morning, all of you. Microprocessor and interfacing. Okay. In this subject, we are able to learn microprocessor and interfacings. First, we will go initially. What are the processor history? We'll go. What is the processor history? Before going to start, a vision of the department and mission of the department. Course objectives are to acquire the knowledge of 8086 microprocessor, to summarize the design aspects of input, output, and memory interfacing circuit, to interface the microprocessor with supporting chips, to explain the architecture of 808551 microcontroller, to demonstrate a microcontroller based system. Course outcomes are acquire the knowledge of basic architecture, operation, programming of microprocessor 8086. Outcome 2, summarize the design of basic and multi-processor system and their bus timings. Then third outcome, design of 8086 interfaces with memory, I/O, and peripheral chips. Fourth outcome, describe the basic architecture of programming of microcontroller 8051. Then fifth outcome, apply the programming concept to implement microcontroller interfaces for different applications. The sixth outcome is the design and construct the microprocessor and microcontroller based systems. This is the syllabus. First unit will discuss about 8086 microprocessor, and second unit will discuss about the system bus architecture and multi-processing, multi-programming. The third unit, I/O interfacing. Fourth unit is microcontroller 8051. Fifth unit, interfacing of microcontrollers. Before going to start the syllabus, we will discuss about the history of microprocessors. The microprocessor means it is a brain of the computer that has been implemented on one semiconductor chip. The words comes from the combination of micro and processor. The processor means a device that processes whatever binary numbers, zeros or one. The process means to manipulate. It describes all the manipulations. Micro means extremely small. Definition of a microprocessor in general term. The microprocessor is a programmable device that takes in a number, perform them arithmetic or logical operations according to the program stored in that memory, and then produces other numbers as a result. Microprocessor is a multi-programmable clock-driven register-based semiconductor device that is used to fetch, process, and execute a data within a fraction of a second. Applications are, these are the variety of applications: calculator, accounting system, games, machines, instrumentation, traffic light controller, multi-user, multifunctional environment, military applications, communication systems. So the microprocessors are available in that variety of processor, like pinless processor, slot processor. These are socket, either socket type, that is processor type, and processor slot type. These are the different processor types of processors are available. Socket type, processor type, and pinless processor, and slot processor, and processor slots. Development of Intel microprocessor. The first microprocessor is developed in 1979, that is 80. The first 16-bit microprocessor. This is a 16-bit microprocessor. Earlier, they will develop only the 8-bit microprocessor. 286 developed in 1982, 386 in 85, then 486 in 89, and for Pentium in 1993. There is a 586, they are called Pentium, 1993. Then Pentium Pro 1995, Pentium MMX 1997, Pentium 2 1997, Pentium 2 Celeron 1998, Pentium 2 Xeon 1998, Pentium 3 in 1999, Pentium 3 Xeon in 1999, Pentium 4 in 2000, Pentium 4 in Xeon in 2000. These are the variety of bits developed by the Intel microprocessor. 8086, 80 means 8-bit microprocessor. 86 from 86 to 486 Pentium up to that Intel dual core Pentium dual core or 32-bit processor. These are the processor and their bits and the speed. The first microprocessor developed by the Intel is 404. It is a 4-bit microprocessor. It could execute around 60,000 instructions per second. The next 4040, it is also a 4-bit microprocessor developed in 1971. Our next 8-bit microprocessor, first 8-bit microprocessor developed in 1972 is Intel 8088. 8088 is a 88 is the second microprocessor developed in 1990s, 1974. It is also a 8-bit microprocessor. Intel, the first successful microprocessor is Intel 80 microprocessor. It was a 8-bit microprocessor of a clock speed of 3 megahertz. It had a 246 instruction. Then 16-bit microprocessor. The first 16-bit microprocessor introduced in late 1978. It is the first 16-bit microprocessor. It had a 22,000 instructions. It includes multiply and divide instructions also. Intel 8088 is a 16-bit microprocessor, but it is only 8-bit external bus. Intel 188 also introduced a 16-bit microprocessor in 1982. Intel 82 is also Intel 80286 is developed in 1982. It is also a 16-bit microprocessor. Next, after that, 16-bit revolution is over. 32-bit processor are coming to the market. The first 32-bit processor is 386, Intel 386, then 486, Pentium, Pentium Pro, Pentium 2, Pentium 2 Xeon, Pentium 3, Pentium 4, introduced in Intel Dual Core introduced in 2006. Okay, in the dual core chips contains 2 CPUs and 2 caches. The bus interface unit is common for both the CPUs. Next, 64-bit microprocessor. Now, Intel Core 2 is a 16-port Intel Core i3, and nowadays up to i9, Intel i9 Core i9 processors are introduced in the market. i5, i7, i9. This is a number of transistor versus a number of years. In 1971, 72, 4004, initially it contains only less than 10,000 transistors. Nowadays, the growth will be more than a million transistors are there in a single chip. Before going to start the subject, the basic terms, a digit is a binary number from 0 to 1. A nipple means 4-bit, byte means 8-bit, word means 16-bit, double word means 32-bit. Data means a binary number or code operated by an instruction. Address, identification of a number for memory location. Clock, square wave used to synchronize the various devices in microprocessor. Memory capacity, 2 power n. N is the number of adder lines. Okay, this is a clock signal, sample clock signals. On period and off period is called entire clock period. This is called clock width. The rising, this is a rising edge, and another one is a falling edge. These are the bus concept. The group of conducting lines carries the data, address, and control signals are called bus. There are 3 different types of buses are there: address bus, data bus, and control bus. The CPU bus means a group of conducting lines directly between the connected to the microprocessor is called CPU bus. System bus, a group of conducting lines carries the data, address, control are called system bus. This is a simple bus architecture, system bus architecture of the microprocessor, general microprocessor circuits. Tri-state logic. Tri-state logic means a device as having 3 states. One is high state. High state means 1. Low state means logic 0. High impedance state. High impedance state means the output is not being driven into any defined logic levels by the output of the circuit. That is called high impedance state. This is a general architecture for any microprocessor that may be 8-bit or 4-bit, 16-bit or 32-bit. It consists of 3 primary units. One is control unit, another one is arithmetic logic unit, and another one is primary storage unit. These 3 will be available in any microprocessor. General from 4-bit microprocessor to 32-bit or nowadays 64-bit microprocessor also there. So all this microprocessor, this is the basic general overview. Any microprocessor consists of control unit that will control the microprocessor, entire microprocessor circuit. Arithmetic logic unit will do the arithmetic and logical calculation. To store the intermediate results, we need storage. So input device means normally a keyboard, mouse. The output device means monitor and printer. Excluding that, the secondary storage devices are also there. Disk tapes, optical device are also called secondary storage devices. Okay, now we'll go to the unit number 1, 8086 microprocessor. First, unit 1 topics are introduction to 8086 microprocessor architecture, addressing mode, instruction set, assembler characters, and assembly language programming. First, we'll go to that Intel 8086 processor introduction. It is launched in 1978. It is a 16-bit microprocessor. It contains 16-bit data bus and 20-bit address bus. So it can be capable of addressing 1 MB memory locations. The address and data lines are multiplexed. Okay. It also can support up to 64 I/O ports. It provides 14 16-bit registers. 8086 requires one one-phase clock with 33% duty cycles to optimize returns. Normally, the three version of 8086 are there. First version is 8086 that uses 5 MHz clock. Then second version uses 8 MHz, that is called 8086-2. Then third version is 8086-1 that is uses 10 MHz clock. That is the internal architecture. In that internal architecture, broadly divided into two units. One is called bus interface unit, another one is called execution unit. Okay, the CPU functions are fetch, decode, and execute the instructions. The fetching operations is done by the bus interface unit. Decode and execution will be done by the execution unit. Okay, bus interface unit only fetches the opcode and data. Decode and execution done by that execution unit. Okay, what are the basic operation of bus interface unit? Send out the address for the memory location, fetches the instruction from the memory, reads or writes the data to the memory, send out the addresses for the I/O ports, read and write out from the I/O ports. These are the operations of bus interface unit. Execution unit, general execution unit tells about the where to fetch the instruction, fetch the instruction or data, decode and execute the instruction, dividing the work between bus interface and execution unit, speed up the processing. This includes the execution bit. It increases the execution bit. Okay. Thank you. We will continue with the next lecture of 8086 architecture. Thank you so much.